All right, Sam. So let's carry on with this. What are we doing last one?
We talked about panning.
Okay.
And the different types of panning that you can use both on headphones and on bigger speakers.
Yeah. And some of them aren't panning. We listened to a mono
different
signal.
ways you can make the sound field sound bigger or different or other than just in the center.
In the center, yeah. And panning is basically putting something louder to one side versus the other. Mono, running to stereo speakers, a mono source would run the same to both. And we looked at altering the delay on one side versus the other, EQ of one side versus the other, compression of one side versus the other, level, which is panning. And then now what we'll do is we'll look at polarity, and we'll also combine up multiples of the other things and see how we can spread the field out without altering the level. So the one thing we're going to not do is pan. We're going to increase the field without...
Because we're thinking about it from a live sound.
Yes, or a coverage type concept, yeah. And that's a great point, live sound.
Because it doesn't really quite matter with headphones, right? If you're just focusing here, I mean, the different types will matter, but we aren't going to be as focused on the left being, or the right being completely different from the left, because it's okay, because it's a singular experience.
I agree. Yes, that's correct. And also at home hi-fi, I mean, you can really push stuff, these instruments to one side or the other, and since you're relatively close to both, it's okay. But the larger the reinforcement venue is, the less you're able to do things like level panning. And you're forced into other stuff. So from a live sound perspective, and then also I'd like to know what you think about this from a speech pathology perspective.
I'm really interested. I have a lot of questions already and I don't know what's out there, but in terms of like, if one of these is easier to listen to like perceptually, which if we're thinking about what is happening with our ears naturally, my guess would be a delay. But it is kind of interesting because obviously audiologists are dealing with people with hearing aid, sound processors, all of these things, and a lot of speech pathologists are going to be dealing with people with auditory processing issues. I don't know if any of this stuff is thought about within that context. So it's really interesting. We're also, like, technology is expanding within that scope in general. It hasn't, I don't know. There's like a lot, it's a very interesting space. But it is interesting because I don't know. There's a lot of questions I have in terms of how this fits in or could fit in, or if it does.
Yeah, and I'm curious to find out as well.
Yeah, and I'll definitely look into it too.
Yeah, I have hands-on experience with this and tools. These are the tools that I use to mix and that I've learned over the years, and finding out how they apply to...
a whole different level in these ways that, like, since being in this program, and we actually have a lot of science and, like hearing science classes, but it is really interesting seeing it from this space and seeing how much of an overlay I think that there is and how much these two fields do not talk at all, really.
I agree. Yeah, there's definitely, there's both in fact, I do have some friends that are audiologists. You know, when we do in-ears and in-ear molding, that's when the live sound field really got exposure to the medical side of things, as they started hiring audiologists to do the injection molding for the ears, and then you start talking to them, and the perception of what is done is completely different. Yeah, and everything's done with these fine levels of finesse and perfection and awkward old prehistoric tools that have we're light years ahead and also light years behind.
It's so interesting because one of the things I think about a lot is just how there are different goals within these two fields, but I think that if you put those goals together, like live sound, there's a lot of money there. There's a lot of work getting to make things sound good, to have wide coverage of how people hear in this specific way. And with the medical side, the goals are kind of different, but I'm like, we don't need to figure out these things alone. Let's bring what we know together and figure out, because there's a lot of stuff here, there's a lot of stuff here. Let's bring it together. And I don't know, it's really fascinating.
Yeah, this is fascinating, and bringing it together. I mean, this is really cool, coming out of live sound world and exposure and sound company stuff into the medical field. As far as there being a lot of money, someone once said a friend of mine's wife worked for a cell phone company. Maybe it was Samsung. It wasn't cell phone. It was Samsung, and they were looking at some numbers, and the entire live sound industry for the United States in its entirety is a rounding error in their accounting. Like, it's just a rounding error. It's irrelevant.
Okay, yeah.
In the medical field, the amount of people spending money on live sound is just a rounding error to real business.
That's interesting. Interesting.
And I think that it's like F1. F1 cars are super expensive and it's high profile, but in relation to the amount of money spent on consumer cars, it's a
nothing.
rounding
It's
error.
a drop in the bucket. I think it's really fascinating. And Allie uses a sound processor, and I went to an audiology appointment, and I was just like looking at all of this stuff and looking at the sound processor, and it's a bone anchored hearing aid. And it was just, there were so many things about it that I was like, oh, why is it done this way? Because like we have so many other technology pieces that feel so like no duh, like this is already here. It's really fascinating, and different goals, and also like people with unilateral hearing loss are not very common. So there's a whole other thing like that. But it's fascinating.
Wonderful. Well, let's get into this.
Yes.
And here's some drums. And we'll go through. And the next one is I put delay on one side. Was it 18 milliseconds?
13.
13 milliseconds. Here's a differential with EQ. And here's a differential with compression.
Okay, yeah.
And back to mono. And now, let's go ahead and listen to Polarity. Now, Polarity is got just one side inverted.
Yeah.
Now, this is an interesting thing. Polarity is very drastic. So, we'll bring that up. There's Polarity. And mono.
Can I hear polarity again? Okay, yeah.
Sounds very stereo. You guys do that with headphones?
Oh wow.
Now the issue with polarity is if we take polarity and we pan this to mono, it cancels out.
Yeah.
So if we just put it at a little bit of panning, it has such a drastic effect. There are people in the center, and it's so volatile as you move around. And let's try it again. It almost tears your head apart. It pulls your brain.
Well, because that was another thing. Thinking about delay and polarity, it's the delay that changes the phasal relationships with the sine waves. That's actually, from my memory in my neuroscience class, is what's giving you the left and right. So it's interesting because polarity and delay end up being the pulled apart pieces of what gives us in our auditory processing.
Delay is like a frequency dependent polarity.
Okay. Can you explain that more?
Well, polarity reverses everything so it cancels.
Delay, yep, gotcha.
It causes some frequencies to be in polarity and some to be out of polarity. And they will be frequency dependent. So it's a frequency dependent polarity shift. With a single sine wave, delay and polarity can be identical.
Yeah. Yes.
Okay, so let's move on. So a polarity, I just want to point out, just in pro audio, putting a polarity reverse is a drastic maneuver that should only be used for specific things. If you want cancellation in the center, be careful with that. Okay, so now what I've done is I've put several of these together. I've done mono. Now this is all mono signal. None of this is stereo. And we've taken a mono signal and I've added delay to one side. I've added compression, and I didn't add polarity, and I've added some EQ. So let's go ahead and compare that. There's mono. do that in headphones? And we'll add some more instruments in.
Wow. Yeah, that's crazy.
And we've been able to achieve all of that without actually introducing a level difference. So in
Yeah.
a live venue, we can have the people in the center hear all this stereo
Yeah.
impact. And this is done drastically. There's a lot more compression I would normally
Yeah.
use. But imposed a lot of stereo-ness without changing the level. So both sides hear very similar volume levels. So that's kind of a dive into aspects of panning or altering
There's-
one side versus the other with a single signal, single mono signal in order to achieve more.
It's like so much more complex than like I even knew, and like I have done sound stuff, and it's just crazy because I don't know. I think that a lot of people, well, the left's a little louder than the right. That's what having that stereo sound is, and like I knew it was more complex, but yeah, it's really interesting pulling these things apart.
Fun.
Yay.
So questions or anything else you want to do?
Yes, I have questions.
Okay.
My first question is when you have the level pan or the pan like knob, is that just doing level pan?
Yes, so we can do that. So what we'll do is we'll solo that up, and you can see this this right here.
And that's just
will be your
pulling-
level pan. And do you want to do headphones or in?
Let's do headphones because people I think will be able to hear it better if
Okay,
they have
great.
headphones.
Well, they'll hear it the same, so they can wear headphones or
'cause
not.
they're
So
hearing it
this
out
is
of
how
this.
we're
Gotcha.
listening,
I
but
like
the
this
signal
better.
going to them's the same.
Delay pans?
What?
Are there delay pans? Like that, like knob wise?
Not really. It's called Haas panning.
Okay,
and it's
Haas
perceptual panning. And
Perceptual.
We
That's
can
so
do
great.
that.
Yeah, at first because it's literally sorry.
so this is. We can mess with the delay there. So we'll just delay on one side. There's that's 40 milliseconds, 70, 70.
Yeah, and that starts breaking apart. It's really only kind of that. You gotta stay lower.
That's 40, 25.
Yeah. And then that sounds, Okay.
And to mono.
Great, yeah. And that's it. Yeah, I mean, it makes sense, the perceptual panning, and it makes sense that I can't remember quite, but there's something with once you get over 30 milliseconds when you're doing like audiology tests, that's kind of the sweet spot for a lot of things. It's because that's when it starts becoming like
Separate sources. Our brain no longer looks at it as a
As a
single
single.
source that has dimension to it or reverberation.
it becomes two separate sources. So that makes sense. Then what I was gonna ask, so I know you obviously have a lot more stuff when you were mixing, especially with like the double mics. What would you do when you were trying to pan? Or get different
all of
levels
the
in?
above.
All of the
All of
above.
the
You
above.
would actually use all of these kind of things.
Yeah, these are now. When I first started mixing, everything was mono. I just
Yeah.
ran kick, snare. Then I started to say, well, there's Power Alley, which is it's super loud and clear at the mixing position, and then off to the sides it wasn't as exciting. And then as I did bigger and bigger venues, I noticed that the sides were less and less covered, less and less
Yeah.
low end. So I started striving for diversifying the low end and getting out of mono subs into stereo subs. And then I started working on carrying that theory all the way up through. Putting two mics on an instrument, miking close with one mic and farther with
Yep.
another, to kind of create this EQ-ish difference. Or once there's another thing we can do, which I didn't do here, which we can put reverberation
Yeah.
on one side more than the other and have them running at the same volume. and one side just sounds more echoey.
Yeah.
And
So then you're gonna-
we'll perceive it more to the left, to the side that's clearer, and less to the other side. Yet, if you don't put too much reverb on there, you can increase the spatialness of it.
Yeah.
The stereoness. Or you could have a stereo reverb. We have reverb on both sides. But minimizing the amount of reverb in echoey environments is usually desirable.
How amazing, because it's just like, this is all playing. Our brains became wired in a specific way of interpreting the world, right? And then we got technology, and we're now recreating these soundscapes, and we're having to kind of like backform and like unprogram a lot of these things and play on them in a different way to get this kind of naturalistic sound, or whatever sound you want. It doesn't just need to be naturalistic. But how fascinating.
Okay, so in the next video, let's chat about the way... I'm going to stop this. Let's chat about the difference between the way we perceive sound versus light.
Okay.
And I have something that may be a unique perspective that you'll find really interesting, and that the way we live our lives, we look at light completely differently than sound, but sound and light are very similar if you look at them in the same way.
We were literally, again, in my neuroscience class, we did our chapter on the cochlea and auditory perception, and then the next chapter was on visual perception, which I have not done the reading or watched the lectures for yet, because I am here instead. But we were like, we can talk about it in the next video. I'm excited.
Yeah, and sound is an energy source. That's a very low frequency compared to light. And light is another energy source, and we have receptors that are our ears that hear the energy source or see the energy source, depending on it. We can hear or feel or perceive things below sound. Like if I shake the table, we can feel, even though it's below 20, we can only hear 20 to 20, but if I shake you, at 5 hertz, you feel it. Perception. We don't see
Or in like that last video that we did, the really high frequency of like 40,000 or something.
We can perceive above 20K through other senses. And the same thing with visuals. We can see visible light, but we can perceive infrared light. We feel it as heat.
Yep.
Just like we feel vibration below. And we can perceive ultraviolet light through sunburns and other methods. So we have perceptions that exceed this.
And there's all of these things that are just in this world, and we have specific receptors that can understand and facilitate, or like take it in and understand it in a certain way, but because our bodies evolved within that space. Okay, cool. I'm excited.
Let's do the next video. Right. And cool, thanks for joining Samantha and I.